So Parkinson's disease affects approximately 100,000 Canadians. Although people normally associate the disease with the elderly, approximately 40% of people diagnosed are actually under the age of 60. Now, some symptoms of Parkinson's disease include muscle rigidity, slowness of movement, and decreased muscle balance. Now, these symptoms all get progressively worse as the disease progresses, and during later stages of the disease, some neurological and psychological symptoms can persist as well. Now, although there are treatments to deal with these symptoms, there's nothing to actually halt the progression of the disease, and this is where our lab comes in. So previous researchers in our lab have been working with a water-soluble formulation of CoQ10. Now, this compound has actually been shown to halt the progression of Parkinson's disease in rat models. Now, this is fantastic. However, we need to be able to show this in a human model. And this is the primary goal of our research, to understand the mechanism to better apply it to human models. Now, CoQ10 may sound kind of familiar. It's actually a natural compound in the body involved in cellular respiration, so therefore it's involved in energy balance and energy maintenance. It's also received some attention in the media recently due to its role in cardiovascular health. It's important that I mention that it's a water-soluble formulation because the lipid-soluble formulation does not actually induce neuroprotection due to problems crossing the blood-brain barrier. So an important characteristic of Parkinson's disease is pronounced inflammation in the brain. Now, as we know from getting a cut or a scrape, inflammation is the body's way of protecting itself. So in a way, you can think of Parkinson's disease as an injury, but to the most important part of the body, the brain. So the brain has these specialized microglial cells, which are immune cells, that secrete factors such as BDNF and GDNF. Now, these factors promote things like cell differentiation, cell proliferation, and cell growth, which are three important aspects of healing. Now, we can test this by measuring the levels of BDNF and GDNF in treated Parkinsonian rats versus untreated Parkinsonian rats. If the levels are higher in the treated group, then this supports our hypothesis. Once we figure out how the mechanism of CoQ10 is actually acting, we are one step closer to actually treating Parkinson's disease instead of just the symptoms.